Why segmentation? The user's view of memory is not the same as the actual physical memory, but with segmentation, the hardware is able to provide a memory mechanism that maps the programmer's view of the actual physical memory. A programmer's view of memory consists of a logical address space. A logical address space is a collection of segments. The addresses specify each address by a segment name and an offset. Usually segments are seen by segment number for simplicity.
Physical memory is a one-dimensional sequence of bytes. We need to define an implementation to map two-dimensional user-defined addresses into one-dimensional physical addresses. To do this, we use a segmentation table. A segmentation table has corresponding segments in main memory. Each entry contains the length of the segment. A byte is needed to determine if segment is already in main memory. Another byte is needed to determine if the segment has already been modified since it has been loaded into main memory. Each entry in the segmentation table has two parts, a segment base and a segment limit. A logical address consists of two parts, a segment number and an offset into that segment. The segment number is used as an index to the segmentation table. When an offset is legal, it is added to the segment base to produce the address in physical memory of the desired byte. The segment table is essentially an array of base and limit register pairs. Here is an example of a few different segments of memory, a segmentation table, and the segments loaded into physical memory. The segment table has separate entries for each segment giving the beginning address of the segment into physical memory and the length of the segment. As you can see, segment 0 is 1000 bytes long and begins at 1400. So if you wanted to refer to a byte that is 50 bytes into segment 0, it'd be referred to from 1450. If you wanted to refer to a byte that was 1200 in segment 0, a trap would be sent to the operating system because segment 0 is not big enough to hold that many bytes since the limit is 1000.
So now that you're all segmentation pros, let me give you a quick analogy to help the information stick. As we learned, segmentation is the process where memory is allocated out in chunks called segments. This allows an application to store various parts of itself and the data that it's working on in different parts of the RAM. Imagine you have a weirdly shaped refrigerator, and this refrigerator, like most refrigerators, is subdivided into shelves that can be moved. In the same way as an application needs storage space, the operating system assigns it shelves that it can use, but these shelves do not necessarily need to be side by side. Say you're making a burger and you've just gotten home with all of your ingredients. Do they need to be stored in the same shelf for you to be able to find them? What if they don't fit on the same shelf? What if there's no room in the shelf above or below either? Can we separate your ingredients and still quickly make your burger the next day? The answer is yes, so long as we know what shelves we have and what we have on each shelf. In the same way, the OS splits up the program into logical parts and stores them in spaces in the RAM in a non-continuous order. So how do we keep track of our shelves? The OS keeps track of the segments by storing them in a segment table. The table stores a segment, the location of the start of the segment, and an offset, the distance from the start, for each segment. We need the offset because not all shelves are the same size. This is because we want to optimize our space usage. If we make all shelves the same size, all shelves need to fit our biggest item, like a gallon of milk. This limits the number of things we can store. If we're able to change the size of our segments, we can store smaller items in a smaller shelves, like egg carton in an egg carton size shelf, and a gallon of milk in a gallon of milk size shelves, thus fitting more items. And that's how you put away your groceries. How segmentation works. I hope this was helpful, and I'll see you next time.